Scientists find monster black holes so big they didn't think it was possible. Before now, scientists did not think it was possible for a stellar black hole to have a mass larger than 20 times that of the Sun, an approximation based on their understanding of the way stars evolve and die in the Milky Way. But that assumption was metaphorically crushed in the gravity of a monster black hole that a group of Chinese-led international scientists discovered inside our own solar system. The hole has a mass 70 times greater than the Sun, researchers said in their study published in the journal Nature, much larger than what astronomers previously thought could exist. No one has ever seen a 70 solar mass stellar black hole anywhere, Joel Bregman, one of the study authors and a professor of astronomy at the University of Michigan, said in an interview. This is the first. Black holes form when a star runs out of fuel and collapses on itself, creating a strong gravitational pull that prevents anything, even light, from escaping. In the process, those stars lose much of their mass, producing black holes that reflect their diminished size. The newly discovered black hole, named LB1 by the team of researchers who published the study, is located 15,000 light-years from Earth, according to a news release. And it is huge. Black holes of such mass should not even exist in our galaxy, according to most of the current models of stellar evolution, Lu Jitheng, a professor at the National Astronomical Observatory of China, said in a news release from the Chinese Academy of Sciences. Now theorists will have to take up the challenge of explaining its formation. Previously, 24 black holes have been discovered and studied in our solar system using X-ray technology that detects a bright light emitted when a black hole eats a neighboring star. While successful, this process limited scientists' ability to find more black holes because the vast majority of them in our galaxy are not actively consuming other stars. LB1 was discovered by China's Large Sky Area Multi-Object Fiber Spectroscopic Telescope, LAMIST, which has provided scientists with a new way to find the estimated 100 million black holes in the Milky Way. LAMIST enables researchers to detect black holes by first tracking stars that are orbiting something invisible to more than the naked eye, like a black hole. When LAMIST identified a star orbiting LB1, the team next used the world's largest telescopes, from the United States and Spain, to take a closer look at the system. The results, according to the news release, were nothing short of fantastic. There are two kinds of black holes. Stellar black holes, like LB1, are made from the evolution and death of stars, which rarely exceed 150 times the mass of the Sun when they are born, Bregman said. There are also supermassive black holes, which almost always live in the center of galaxies and range from 1 million to a few billion times the mass of the Sun. Our own galaxy, the Milky Way, has a supermassive black hole in the center that is a mass of approximately 4 million suns. How supermassives form is unclear, Bregman said, but it's possible they are created when stellar black holes merge. Black holes are basically the most mysterious objects in the cosmos, Shep Doelman, the director of the Global Event Horizon Telescope Array, has previously told the Post. Even Albert Einstein almost didn't believe they were real, he said, even though it was his theory of general relativity that helped predict them more than 100 years ago. Black holes are the most exotic animals in the cosmological zoo, Doelman said. Scientists can learn a great deal about the universe by studying what they eat and how they behave. Bregman said scientists are always trying to learn more about the birth and death of stars, and the discovery of one as large as LB1 could inform that process. Is this object extremely unusual? Or is it more common than we thought? Bregman said. If we look at 20 black holes and find 2 of 3 of these things, that would be truly amazing. It would change ideas of how massive stars evolve and die.